All right. In this section, we're going to look at fractions. We're going to talk about common denominators. Now, we're used to or familiar with common denominators when we just have numbers in the denominator. Like, what's the common denominator for 5 and 4? Well, sometimes to get the common denominator, you literally just have to multiply the two numbers together. And so 20 would be the common denominator. And so that means we would end up taking the top and the bottom of this fraction times 4, the top and the bottom of this fraction times 5, and then they would have common denominators, and we could add them or subtract them or whatever it asks us to do, okay? So sometimes you literally just take the two denominators and multiply them together. Sometimes you don't have to do that, though. To get a common denominator for 2 and 8, I don't have to go 2 times 8 and get 16, because I can turn 2 into 8 just by multiplying. And so the least common denominator here, sometimes referred to as the LCD, is 8, all right? Because I can turn this into 8 very easily, all right? Well, so now we're going to have rational expressions, or x's and binomials and trinomials, and sometimes I've got an x minus 3, I've got a 2x plus 3. Sometimes there will, all you can do is multiply the two denominators together. The common denominator, the least common the least common denominator for these two expressions is x minus 3 times 2x plus 3. That's all we can do, right? But in this one, think about x squared minus 4. Wait a second. That is a difference of squares. It's x minus 2 times x minus 2. So I can turn this into x minus 2 times x minus 2 by simply multiplying the top and the bottom by x minus 2. And now I'll have two common denominators. Okay? So hopefully that makes some sense as to how we actually get the denominators to be the same. Because guess what they're going to ask you to do now? They're going to ask you to add fractions together or subtract fractions. And you're going to have to determine what's the common denominator, the least common denominator. Well, we got lucky right here, didn't we? They already have common denominators. And when we add fractions, we don't change denominators, right? And we simply go across the top. What's 2 plus x? Well, the last time I checked, it was 2 plus x. And so this would be the answer to that question, all right? Easy enough, because we didn't have to do anything to find common denominators. They were already common. But now they're not common. But isn't this a difference of squares? Isn't that x minus 5 times x minus 5? And so if I simply multiply this top and bottom by x minus 5, now they will be the same. Okay? But so now we've got them the same, but now we got to pay attention to the numerators. We got to multiply this out. That becomes 3x squared minus 15x, and then minus 2. Well, 3x squared minus 15x minus 2 over x squared minus 25. And that's probably all you can do. All right? So get your common denominators and then do the addition or subtract. Make sure you get the numerator the way it's supposed to be, do the multiplication, and then get your answer. Ooh, now we've got 3 fractions, and we've got 3 fractions, 2 subtractions, and the denominators are not common. But look at this. Are there any factors of 6 that add up to 5? Well, 3 and 2. Now notice, so I can turn this into that simply by multiplying by x plus 2, right? And I can turn this into that simply by multiplying by x plus 3. And this one is already good. And so do you see what we've done there? I'm multiplying first fraction by x plus 2, top and bottom. I'm multiplying the second fraction by x plus 3, top and bottom. so that the denominators will be exactly the same. All right? And so now I'm just going to write out the numerators here. X squared plus 2x. Now be careful. There's a subtraction sign here, and I've got more than one number. I'm going to have to put that in parentheses. 3x plus 9, and then minus 1. And because that's in parentheses, this is really x squared plus 2x minus 3x. Here's the thing that gets people. Minus 9 minus 1. You have to distribute that negative sign through there. So x squared, 2x minus 3x would be negative 1x. Minus 9 minus 1 is negative 10. What's the denominator? It's x plus 3 times x plus 2. Final answer. All right? So it's a little involved sometimes, but once you find what your common denominator is going to be, then it allows you to start messing with the numerator, and that's where the work is. That's where the math takes place, up top in the numerator. Okay? Now, the last part of this assignment has what they call complex fractions, all right? And it's complex because there's just fractions all over the place, all right? Multiple fractions in the numerator and another fraction in the denominator, okay? Well, I'm really okay. If you gave me x over 3 divided by, y over 4, I can handle that because that's just x divided by x over 3 divided by y over 4, and I know that, that just simply means times 4 over y, and we could multiply across the top, multiply across the bottom, 4x over 3y, got our answer, okay? And so that's what we're wanting, but before we can do that here, we've got to combine these two, this addition problem in the top. And it looks like we're going to have to get a common denominator because they aren't the same. And it looks like we just need to multiply, we got to multiply this by x minus 1, and we got to multiply this by x. That's all we can do. It's one of those like 5 and 4, the common denominator is 20. You just got to multiply them together. So let's take a look at this. That's going to be 2x minus 2. It's a plus sign, plus 3x. That's what my numerator is going to be, all right? And we can combine that together and get 5x minus 2 over x times x minus 1. All right? And then that is divided by 1 over 2x minus 2. So now I'm going to take 5x minus 2 over x times x minus 1, and I'm going to write it like this. See, all I did was, instead of writing a fraction bar, I wrote a division sign. Why? Well, because I know that when I'm dividing fractions, I'm really multiplying by the reciprocal. Hey, I think 2x minus 2 can be factored. Yeah? Can't you take a 2 out of there? Look at this. Boom. So this isn't here anymore. The only thing that's left of that is the 2. So really all I have is 5x minus 2 times 2 over what's left down there, an x. And so I guess we could call that 10x minus 4 because we can distribute that over x. Okay? It may seem long and complicated, and it is long, but if you just focus on first step, add those two fractions together. If there were multiple fractions in the denominator, add or subtract them. Because I want to get to the point where I've got one fraction in the top, one fraction in the bottom, and then I can move to actually finishing the problem. All right? Hope that helps.